Imagine calculus as a superpower. Calculus gives you two amazing superpowers, zoom vision and speed sense. Superpower 1: zoom vision, also known as differentiation. Think of a roller coaster. From afar, it just looks like a bunch of twists and turns. But what if you could zoom in on a tiny piece of the track? Differentiation lets you do that. It's like having super zoom glasses to see each little segment of the track up close. With zoom vision, you can find the slope of the roller coaster at any point. The slope tells you how steep the track is and whether it's going up or down, moment by moment. In calculus terms, finding the slope at an instant is called finding the derivative. So, when you're zoomed in on a curvy roller coaster with differentiation, you're able to know the exact steepness or instantaneous rate of change at any point. Whether the roller coaster is going up fast, dipping down, or moving smoothly, differentiation can tell you all about it. Superpower 2: speed sense, also known as integration. Now let's say you hop on the roller coaster. You start at the beginning of the ride and feel every twist, turn, and drop until the very end. Integration is like having a superpower that lets you sense the whole journey and add up every little bit of it to find the total distance you traveled. Think of integration as adding up tons of tiny bits of area under the curve of your roller coaster. If each little piece of track is a tiny distance, adding them up gives you the total length of the ride. It's like calculus's way of saying, let's add up every little moment of your journey. In math terms, integration allows you to find the area under a curve, which helps us figure out things like total distance traveled, total work done, or even the total energy used over time. So if differentiation tells us what's happening at a single point, integration is more like the big picture, seeing the cumulative result. The plot twist: they're opposites. Differentiation and integration might feel like opposites, and in a way, they are. Differentiation takes a big picture and zooms in to see the detail at each point, while integration takes a lot of tiny details and zooms out to see the big picture. Think of it this way: if you know how fast you're going, your speed differentiation lets you figure out how quickly your speed is changing. But if you know your speed over time, integration helps you figure out the total distance you've traveled. Calculus connects these two in a cool, cyclical way, where each one can undo the other. That's called the fundamental theorem of calculus, the rule that says differentiation and integration are two sides of the same coin. Everyday examples. Driving a car. If you have a speedometer showing how fast you're going, instantaneous rate of change, that's like using differentiation. But if you want to know the total distance you've traveled, you're integrating all those little speed readings over time, making a smoothie. Imagine blending a smoothie with different fruits in specific ratios. Differentiation helps you know the flavor at any given spoonful, the precise fruit-to-fruit ratio, while integration is like saying, let's blend it all together to make one smoothie. Why it's fun: calculus lets you predict and control. Calculus isn't just about numbers, it's about understanding and predicting change. Want to know where a rocket will land? Or how fast a plant will grow if given sunlight? Calculus gives you tools to make predictions. You're able to step into the flow of things that change and describe, control, and even optimize them. So next time you think about calculus, imagine putting on your superhero cape with zoom vision and speed sense. Calculus makes the mysteries of change and motion clear and actionable. And that's what makes it so powerful and surprisingly fun.